everyone. Welcome to the Carolina Weather Group. We're happy to have you this evening, and we want to welcome our guest, Mr. Stephen Baxter. He works for NOAA headquarters. He is the Winter Weather Services Program Lead, and we're getting into that season where we're transitioning more into fall and winter, and with that comes the threat of winter weather, and that's what we're going to be talking about tonight. It's going to be kind of twofold. NOAA just recently released the winter outlook for the 2021 winter season. So we're going to go over that briefly, and then we're also going to talk about a new product that NOAA is releasing. And this is kind of similar to what we see in the summertime with storms, the threat of storms. So it's going to be a new outlook that we're going to talk about and really dig into, because this is a new product and one I think everybody will find useful. So we'd love for you to join in on the conversation as you're watching tonight. Feel free to drop any comments if you want to. Stephen, welcome to the show, and thank you for joining us tonight. I know kind of a busy season with you getting ready and ramping up for the winter weather season. One thing we always like to ask our first-time guests, and we talked a little bit about this off air, but we'll go through the short, brief version. Tell us about your weather journey. How did you kind of get hooked into the weather field, and how did you get to where you're at right now with NOAA?
Yeah. So my interest in weather started at a young age. A lot of us have some formative moment where we decided that we wanted to be meteorologists. Mine was the blizzard of '96, early January of '96. I was in second grade, and I still remember it quite vividly, actually, watching the Weather Channel and watching the local on the 8s every 10 minutes. And I think my parents thought there was something legitimately wrong with me as I was just watching this constantly. I loved it. I was hooked. And so I love winter weather. That's always been my favorite type of weather. And so I went to Millersville University in Pennsylvania, where I got my bachelor's degree in meteorology. When I was there, I was lucky enough to do an internship at the time. Was called the Student Career Experience Program. Now it's called the Pathways Program. It's actually a broader, it's not just the Weather Service, but it's a broader federal initiative. But I did for the Climate Prediction Center. And I worked there, including that time, for 10 years, about 10 and a half years before I went to headquarters. And so I worked in a couple different positions in the Climate Prediction Center, but I did a lot of research to operations of applied research in climate variability, subseasonal, seasonal climate variability. And as part of a rotational assignment last winter, I worked over in headquarters in the winter program. And then I took that position permanently during this summer. And so that's what brings me here tonight. So I'm pretty new in that position. So I'm still doing a lot of spinning up. There's a lot to learn. There's a lot of awesome stuff and great people throughout the agency. And going from climate to weather, which is kind of funny to say in the Weather Service, but to do that and to do that with winter weather, which is our newest service program, is a lot of fun. But there's a lot to learn, and there's a lot of work that we have to do. But we're really happy with where things have gone recently, and I'm happy to be here tonight to talk about some of that progress.
Well, speaking of the National Weather Service and NOAA, they have just released their 2020-2021. It's kind of a mouthful. Winter weather outlook, and La Nina has been a word that's been talked about a lot, and some of our viewers may not fully understand what a La Nina is. So what is the winter outlook, and how does La Nina play into that?
Great question. So we start with La Nina. So La Nina is called the cold phase of what we call the El Nino Southern Oscillation. So the reason this is important is because the tropical Pacific is an important heat source in generating convection in big swaths of thunderstorms across the equator, especially in the central western Pacific. And that plays a really critical role in the formation and maintenance of the climate as we observe it even in the mid-latitudes, namely through the formation of the jet stream. And what happens during La Nina and El Nino is the sea surface temperatures in the Pacific are either warmer in the case of El Nino or colder in the case of La Nina. And what that does is it alters relative to normal those patterns of tropical convection. And that in turn affects the jet stream across the North Pacific especially. And that has, through what we call teleconnections. So I think a lot of weather folks or people who love weather are familiar with teleconnections like the North Atlantic Oscillation, for instance, or the Pacific North America pattern is another prominent teleconnection. And so itself imparts an extratropical teleconnection, and so is the El Nino Southern Oscillation. And so that kind of classic La Nina teleconnection, if you will, is what drives in large part the outlook for the upcoming winter. And so if you look at the forecasts that were published by the Climate Prediction Center, so I used to do these outlooks until about 3 or 4 months ago, you'll see that there's kind of a very typical La Nina type pattern that you might be familiar with, which shows, generally speaking, milder than normal conditions across the southern tier of the United States are favored. And then across the northern tier of the U.S., especially across the north central, northwestern parts of the U.S., colder than normal temperatures are favored. And then actually El Nino actually has a slightly stronger precipitation footprint than temperature, in fact. And across the southern tier of the U.S., drier than normal conditions are favored in La Nina. And across the northern tier, generally speaking, it's wetter. But there's kind of 2 centers of action you'll see. So one is in the Ohio Valley, which tends to favor wetter than normal conditions to the Ohio Valley and the Great Lakes. And then again across parts of the northern Rockies and the interior Northwest. So it's a pretty classic look that you see in La Nina winters. And it's fairly close to the exact opposite of what you see in El Nino. Not exactly. There's some interesting reasons for that. But generally speaking, with a moderate-ish, maybe strong La Nina this winter, certainly a robust La Nina event, that's going to have an important impact. And so that's what forms the basis for that winter outlook.
So in regards to the La Nina oscillation, what about the NAO, the North Atlantic Oscillation? Are there any trends regarding what the outlook might be for this season?
Another great question. So this is actually something I worked on quite a bit while I was at CPC for the last few years. So the short answer is not really-ish. So the NAO is a very important pattern of climate variability across timescales. So we know it's important for short-term climate variability for the next week or two. We know it varies on longer timescales, potentially up to decadal timescales. The problem is the ability to predict it on seasonal timescales, especially once you remove a little bit of a La Nina influence. So the way the NAO is calculated, right? So you think one way you can think about the NAO, or one way it's calculated, is by looking at the relative sea level pressure anomalies in the North Atlantic between, say, near Iceland and the Azores to the south. Well, if you just take El Nino or La Nina and you look at this wave pattern that comes out of the tropics, and you look at the teleconnection that's imparted from El Nino and La Nina, it will have a non-zero effect in the North Atlantic. It's small, but non-zero in a way that can appear to affect the NAO. And so there's some literature that in our academic literature that looks at the relationship between El Nino and NAO. And such as it is, you might favor a positive NAO during La Nina winters, but that's not, as a causal mechanism, is a little flimsy. The example I just gave, quite famously, the 95-96 winter was such a winter where you had a La Nina, but you also actually had a predominance of the negative phase of NAO, and hence one of the snowier winters on record across much of the eastern U.S., including my part of the Mid-Atlantic. But there are some interesting areas of research related to identifying sources of prediction skill for the NAO, and so it's something that we don't have right now. But I'm hopeful that in coming years, we'll be able to talk more explicitly about the seasonal tendencies of the NAO, or sometimes it's couched in its sister oscillation called the Arctic Oscillation, the AO, which is kind of more of a hemispheric look. They're just kind of derived slightly differently, but capture the same, in essence, the same phenomenon. So I'm hopeful that in future years we'll be able to say something more specific about these patterns of mid-latitude variability. Unfortunately, in this winter outlook, and what we're comfortable imparting in the current outlooks from the state of the science, wouldn't really support that right quite yet. But it's a good question. It's something that we think a lot about.
If I was approaching from the general public and I wanted to take a look at the 4 different colors that were available that represented the outlook. Can you tell me a little bit about what those colors mean and how are they decided?
In the case of the winter storm outlook, there's a few different, we added an 80% this year. So there's a less than 10% chance, which won't show up as any color. There's 10 to 30, 30 to 50, and 50 to 80, and then there's in excess of 80%. And so that's the probability of exceeding that local watch warning criteria. Now, how do we come with this? And so in that sense, those are meant to just kind of fairly easily communicate what the relevant risks are. We can think of 50% as kind of being, roughly speaking, the criteria for a watch. So if it's more likely than not, that would favor a watch. Now, also, it's important to mention that this doesn't take the place of or totally inform watches, because as we're moving towards consistent forecasts across the agency, the other aspect that we're working with is to also improve the impacts-based nature of watches and warnings. So while the probability of exceeding a certain snowfall threshold might say only be 30 or 40%, the local office could still issue a winter storm watch because they're expecting the impacts from that storm to be such that it warrants a watch or a warning. So cases where this gets a little slippery are where you have mixed precipitation, where you have sub-warning criteria in both snow and ice, situations where shoulder seasons, and we saw some examples of this earlier this year, especially in the Central Rockies, where snowfall events that are early in the season with foliage still in the trees, and so snow load and power outages are more of a concern. You might issue watches and warnings for lower snow accumulation criteria because of the increased impacts. And then a classic example here in the East is timing is very important. So heavy snow during rush hour, for instance, is more impactful than heavy snow during the middle of the night on a weekend or something like that. So those are local impacts that local offices can take into account. So it's not a one-to-one correspondence yet, but that's kind of loosely speaking. 50% is where, all things being equal, you would start to think about you would issue the watch, because that's where we're saying it's based on the reliable probabilistic guidance. It's more likely than not, so it's worth issuing the watch. But that can be modified by the local office's take on the expected impacts of the storm.
I know impacts is a big deal, and I know each forecast office has different criterias. First thing that pops into my mind would be the Atlanta snow jam in 2014, where, we had maybe an inch of snow, but the temperatures were so cold. So it seems like this product that you guys are releasing is really more based on impacts and how it impacts the general public, emergency management, and things like that, than it is maybe about this set range of you're going to get this much snowfall.
That's right. So there's another product that is a very nice complement to this that's been operationally implemented this year, which is the Winter Storm Severity Index. And so what that does is it has criteria, but it's a much more complex and dynamic criteria to better account for some of these impacts. And so in that framework, where you have, and so what it's doing is it's screening the official forecasts from the National Digital Forecast Database. So the local offices are submitting their official forecasts. It's using those forecasts, applying climatology, applying different algorithms to assess different impacts, including snow amount, snow load, ice accumulation, ice impacts, among other things. And it's doing that to get an idea for those impacts, including things like flash freeze, blowing snow. And so using those two together, and as in fact, the vision of the program is kind of an eventual merger of those two products along the lines of what you were saying. So right now, the Winter Storm Outlook is grounded in the very objective kind of criteria-driven realm. The Winter Storm Severity Index is still deterministic, so we're not using probability information yet. It's just using the deterministic forecast from the local offices, but it's applying it in an impacts-based context. So our long-term goal is to get to a place where we have a probabilistic Winter Storm Severity Index that will in turn inform the winter storm outlook, so that the winter storm outlook today, being just the probability of exceeding a fixed snow or ice accumulation threshold, will eventually be the probability of exceeding moderate or severe impacts. impacts being defined, being kind of regionally varying and defined in a much more nuanced fashion. And so it's those two products right now that are a nice complement that we eventually want to see kind of come together and form the basis of these kind of consistent, collaborated, and probabilistic products across the agency.
I think a lot of people hear outlooks and they are thinking of the Storm Prediction Center outlooks for severe weather that they might be familiar with. How might these new experimental outlooks compare to those?
So they might be, they are potentially similar in that they're probabilistic. They're giving a probability of a certain event occurring in a daily cadence. So we have day 1, day 2, day 3, day 4, and then the maximum probability across days 1 to 4. That will be different. The Storm Prediction Center doesn't have that component. So they're very similar in that they're trying to give advanced lead time and a heads up, right, in terms of hazardous weather. So the Storm Prediction Center, as you might know, issues severe thunderstorm watches and tornado watches for the CONUS. And as you might imagine, their objective probabilistic outlooks, convective outlooks, play an important role in that, and starting that process through which they work with the local offices to issue those watches. And so that's actually one of the we're leaning in on that paradigm a bit in the winter program. Not to say that WPC is going to take over watches entirely, a la kind of the SBC model, but to say that we're moving in a direction where those watches are going to be more closely collaborated in an explicit and defined fashion and process between the local offices and WPC. And so, yeah, I think there is a lot of, you can draw a pretty close parallel between those two. And in a lot of ways, the winter program is trying to lean in on the probabilistic element. I think it's recognized how important that is in severe weather, because it's, we kind of, I think it's intuitive, right, that the odds of a tornado, for instance, at an exact grid point at any time is very, very small. And so specifically, right, in SPC space, the outlooks of the probability of the event occurring within 25 miles of the point, right? And so it's this kind of stenciling out of the grid. And in winter, that's not so much our problem, but we do have the problem of conveying the uncertainty in the forecast. So when you're issuing a forecast for winter weather, we need to know how much liquid equivalent precipitation is falling and its phase, and if it's snow, right, the snow liquid ratio, which can vary as well. And so there's a lot of degrees of freedom there. And so it's important that we flesh out all those possibilities. That's why the probabilistic forecasts are so important. And then once we have that suite of probabilistic forecasts, we can kind of take a slice through them and look for these cutoff points where the probability of exceeding a hazardous criteria is enough to warrant kind of these public messages, like a winter storm watch, for instance.
As far as who this product's actually meant to kind of serve the best, on your product description document, it talks about emergency services, different kind of broadcast elements, and it also mentions the general public as well. Can you kind of elaborate a little more on that?
So the product actually has its background in a watch collaborator tool that was an internal tool to help forecasters collaborate between the national centers and the local offices. And basically the idea was to broaden it up and give some of our stakeholders, including the general public, access to this kind of national picture image that gives you the probability of hazardous winter weather at extending lead time, right? So day 1, 2, 3, 4, and in a way that, again, just kind of improves the situational awareness for stakeholders in the general public, as well as the ones you mentioned, like emergency managers and kind of those other stakeholders that work closely with the local offices, and to give them, I know Scotty, you had mentioned, talking with the meteorologist at GSP, kind of another tool in the toolbox, right? And so that's the idea here, is that we're giving the general public, as well as more sophisticated, maybe decision makers, not to say that the general public's not sophisticated, but the general public, as well as more acute decision makers, another tool in the toolbox to improve situational awareness, to understand the threat of hazardous winter weather, but also to highlight areas where maybe the threat of winter weather is lower than would qualify for a watch, but where certain very sensitive industries might still want to be aware of that. And so it's also an opportunity to better inform the public and those stakeholders about the utility of probabilistic forecasts and how we use them.
So how can the public give feedback on this?
So it is important when we have experimental products. So the process that we go through in the Weather Service is when we have an experimental product like this, it goes out for what we call an experimental comment and review period. So it's reviewed not just by internal meteorologists, but it's also being reviewed by the general public. And so if you go to the Winter Storm Outlook website, which is hosted by the Weather Prediction Center, there's a link there at the top where you can provide feedback in a survey to give feedback on anything from there's a set list of questions, but it will include things like the scientific integrity, the accuracy of the product, but as well as the aesthetics of the product. Does the display make sense? Does the web page make sense? Is the data easy to access? I do think the Weather Prediction Center has done a really awesome job with that website. It's dynamic. It's in GIS format. You can download the shape files, KMLs. You can pull static images if you want. So there's a lot of great ability to get hands-on with the data there. It has custom level zooms to each of the county warning areas. So for each office, you can kind of get a zoom in to whatever office, whatever area of the country you're in. So it's really a very accessible website, but it can certainly be improved, I'm sure, based on the feedback that we get from the public. And in fact, that's actually important. I'm glad you asked that question, because last year, like I said, this is the second year that this has been experimental. In the first year, last year, we didn't get a whole lot of public comment on it. And I think it might have just been an awareness thing. A lot of people weren't as aware that this existed, that this product was out there, and that we were looking for comment on it. And so hopefully one of our goals this year is to hopefully get more public feedback. And that's not only important to help us improve the product, that is important, but also helps us make the case to organizational leadership that this is a product that we want to support operationally. It's not a foregone conclusion that this will be around forever, right? If the feedback's not positive or not sufficient or it can't be resourced, we might have to discontinue the product, right? So experimental products aren't guaranteed to continue forever. And so it helps us build that case to transition it to operations, or to make improvements and then transition to operations in a way that keeps our program and our programmatic goals moving forward.
Well, speaking as a daily GIS user, that new user-friendly interface sounds awesome, and I'm really glad that opportunity is going to be there. Lastly, are there any other winter weather products that y'all are working on besides this winter weather outlook? So
that's a great question. So the Winter Storm Outlook, that's experimental right now. I did mention the Winter Storm Severity Index that's operational. Okay, so that went through this experimental process and has been implemented operationally this year. So a few key initiatives that we're working on that I'll just run over real quick, and they're kind of in experimental space or in development space, just things to look for. But these are just kind of general things that we're interested in from a programmatic perspective. I mentioned moving these products through the medium range, and so extending the Winter Storm Severity Index and the Winter Storm Outlook through day 7 is an important priority. I touched on briefly the development of a probabilistic impact-based component. So a Winter Storm Severity Index that's in probability form. That's something that we're working toward. We're working with kind of the research arm of the Weather Service to help kind of move that along and get that into the operational pipeline eventually. And then lastly, one of the things that you might also be familiar with is there's the local probabilistic snow experiment. So at the local level, if you go to your weather.gov/3 digits like GSP, although I'm not certain that GSP is participating in the experiment, but supposing it is, if you do /winter, right, you get the main winter page, and one of them is the probabilistic snow forecast. So it shows the expected value and then the high end and low end amounts. And so those are the 10th and 90th percentiles respectively. And what we're working on there is that's been experimental for some time, and we're trying to get that on a path to operations, and including probabilistic ice forecasts with that. That might be especially relevant in your part of the country, where one of the parts of the country where you get a lot of interesting icing events. And so that's a complicated issue organizationally that we're working through. And it's something that we're trying to make some progress on, but we're looking forward to there being some experimental changes and then getting that on a path to operations. And so as we kind of tying the kind of what I kind of say like the synoptic scale evolution of the winter program is looking at a future in a few years where you have a probabilistic impacts-based guidance informing the winter storm outlook that's supporting consistent and collaborated winter storm watches around the country. And all of that is being undergirded by a consistent national to local suite of probabilistic snow and ice forecasts, and potentially extended all the way through day 7 across the board. And with that kind of, and that's kind of that, like I said, synoptic scale. And then longer term, one of the things that we know is important is being able to improve the storm scale side of winter weather forecasting. Heavy snow bands, snowfall rates, hourly snowfall rates, for instance. Those are things that are really important for impacts. We're talking about impacts. Looking at a 6-hour accumulation, 3 inches of snow in 6 hours. That's nice. If that 3 inches occurs in 1 hour, that's very impactful. If it's a half inch an hour for 6 hours, that's less impactful in an acute sense, right? So those kinds of storm scale, micro mesos type scale storm impacts is something that we're also working on as well. And so that's a little farther out in our planning process, but something that we're really aware of as being an important issue that we need to tackle to keep making progress on all the kind of important aspects of winter weather.
And for our Carolina viewers, I was just checking as Stephen explained that, and there NWS GSP, along with potentially other offices across the Carolinas, do offer that winter weather experimental product to see the 10% and 90th percentiles. That's
yes.
Weather.gov /GSP /winter.
Winter. It is there. Yeah. And you'll see it. It'll the probabilistic snow. Yeah. Yeah. There's 70, I believe it's 76 or 76 offices around the country offer it. So it's not in every office. It's not even in every office that theoretically can have winter weather. As you might imagine, offices in parts of the deep South or Southwest and the West Coast aren't participating in the experiment. But I'm glad to hear that those parts of the Carolinas are. So that's something to definitely check out at your local office as you go through this winter season. And another opportunity to provide feedback as well. As we're going through this season, because that's an experimental product, if you go to that website that Evan just mentioned, you can also click, there's a feedback link there that'll take you to another one of those surveys to provide that feedback to us.
Well, Stephen, we appreciate your time tonight. Since you're the program lead, this is your time to let everyone know again how they can find out about all this information. I know you guys are hoping for a lot of feedback. So where should our folks go to find the outlooks and the severity index? And again, remind us how we can provide that feedback for you all.
The easiest place to go to get started on this is to go to the Weather Prediction Center's website. That's wpc.nsep.noaa.gov. There might be some shortcut versions of that also. And under their winter weather tab, on the options panel on the left, you can select the experimental winter storm outlook or the winter storm severity index. I think the WSSI might actually be linked at the top of their homepage. And then for the winter storm outlook, that's the experimental product for which they can give a lot of input. For more information on the winter outlook itself, I would recommend going to the Climate Prediction Center homepage. And they'll have a link to the latest press release from NOAA that was put together, and that whole forecast put together by my former colleagues at the Climate Prediction Center. And you can read more about that there. Awesome.
Well, thank you, Stephen. And thank you guys for watching us tonight. If you're a big winter weather lover, hopefully you'll be able to use these products. I know last year was kind of a bust for much of the Carolinas winter weather-wise. So maybe this year we'll be able to use these products, and definitely recommend that you give some feedback.
Full disclosure, right? In a La Nina winter, it doesn't look good.
It doesn't. You're right.
It only takes
one.
And these are all probabilistic forecasts, so you can get lucky, and you can pull a rabbit out of the hat here and get some winter. So I'll certainly be rooting for it. But La Nina winters are not typically our winters here in the eastern part of the U.S., especially the southeastern part of the U.S. Unfortunately, but
that's it.
But you never know.
You never know. It's like we talk about the hurricane season. It only takes one. So hopefully, if we do get that one storm, you'll be able to use these products and definitely provide some feedback. I personally think it's a great product, and hopefully it'll get out of the experimental stage and into operational stage. So Stephen, thank you again for watching. Thank you all for watching tonight. We'll see you real soon.